Okay, so last class on Monday, before our quiz, we talked about graphing inequalities. Now, in the past, we talked about systems of equations also. Systems of equations is where two functions intersect the points that they have in common. So today, we're going to put those two ideas together. We're going to talk about systems of inequalities. Okay, systems of inequalities. So let's take a look at that. So we'll talk about what that is first, and then we'll talk about how to graph it. It's going to involve both linear and quadratic ones. So first of all, what is a system of linear inequalities? It's basically when you have two inequalities, and we know, like, for instance, let's think of a point that works for this one here. How about if I plug in 2 for x, what could be a good value for y to make it a true statement? If I plug in 2 for x, what would be a good value for y to make it a true statement? Huh? 5 would work. What else? 1 would not work. Here's why. Because if I plug in 2, I get 5 there. If I put a 1 there, 5 is not greater than or 1 is not less than or equal to 5. So, but 5 would work in this case because there's an equal sign. So if I put a 5 here and a 2 here, you get 5 is less than or equal to 5. What else could work, guys? So we got 2, 5. What else? Give me another number. It's out there, so we're not too sure. So the point is, if I plug in 2, I get 5 on this side. Now, we already said 5 works. That's because 5 is equal to 5. But it could also be, we want this side to be less than 5. So, oh, you were right then. 1 does work. Because 1 is less than 5. Good. What else would work now? 2 would work. What else? 3, right? Okay, so there's an infinite number of answers. Anything less than 5 would work. Okay? So, well, what about this one? This one has some numbers that would work too. Like if I plugged in 2, I would get 4 minus 4 plus 1. So this side would be 1. So what could go over here? 3? Yeah. It's got to be bigger, right? Or 4, right? Now, a system of equations is where they have points in common. So I want to find out what points does this one have in common with this one. Now, there's an infinite number of possibilities, so you can't really write them all out. So instead, what we're going to do is we're going to graph it to show where all the answers are. And the graph is going to be where the shaded areas overlap. So let me show that to you. So let's take a look at this. Suppose I had this function here on the left, x plus 3. Where would I shade this one? On the bottom. We know that from yesterday. Whenever, when y is less than, we shade underneath. How about this guy here? Where would I shade this one? I would shade above, so that's going to look like kind of like inside. Now, what if I put those together? Let's take a look. So if I were to shade, now if you're using a pencil, I'll show you what I do. Instead of using colors, I'll shade underneath. So let's, like we said over here, we're shading underneath of that line, right? Like this. So that's like the yellow area over here for the line. Now the purple one, let's shade with diagonal lines going in the other way. And when you do that, it kind of creates like a little waffle area. Do you guys see the area that kind of looks like a waffle? That's where they overlap, is right in here. These are the points that are shaded for both functions, and those are the points that would work. So that's how we're going to describe all the points that they would have in common, is by just basically doing what we did yesterday twice on the same graph and finding out where those areas overlap. That's pretty much the idea. All right. So let's go ahead and take a look at example 1 here, and then we'll work through it. So I give you the graphs. later, in our next example, you guys are going to create your own graphs, but for now I'm giving you the graph. So I give you two functions here. You got to be able to tell which one is which. That's kind of an important thing to be able to tell. Which shape is this? It's a quadratic, and what do quadratics look like? They look like a U shape. So we know it's a quadratic because there's a square there. Okay? So we know that's the U shape. So we know that's this one. Another way you could tell, although this is a little bit less reliable, is this is the one with the equal sign underneath. So that's the solid line. That's another way you could tell. But what if they were both solid lines? That wouldn't be very helpful. All right? So that means this other one here, which doesn't have a square, is the straight line. So I'm going to color code those just for teaching purposes. If you have different colored pencils, it might help though. But there it is. So we want to shade. So for the purple line, where am I supposed to shade? Above it, because it says y is greater than, right? So I'm going to shade above it. Above the purple line. I'm just going to pretend like the parabola is not there right now. I'm just going to color right over it. So any point in that area up there is a solution. Okay? Now, what about the red line? Where am I supposed to shade for that one? Well, we don't say inside. We either say above or below. So let's take a look at it. What would I shade, above or below?
Below.
Above. Because see how it says y is greater than? So we're going to shade above it. What would that look like? These are all above the red line. Now that looks like a hot mess. Okay? So, but do you guys see where the purple and red are overlapping? I'm gonna give you guys some options here. You don't have to, don't write this on your paper, but we have a few areas here. I'm gonna shade them really quick, and I want you to ask me if they're the solution. Is this the solution area here? No. Why? There's no red there. It's just purple, right? So that's not the answer. How about down here? No, there's nothing there. That doesn't work for either equation. How about here? Yeah, that's an area. How about down here? No. All right. Now what I'm going to do, and if you have a pencil, you could do this too. Is you don't have to. I mean, if you can see it and not be confused, that's fine. But what I like to do, so I'm a little bit less confused, is I like to erase stuff that I don't want. So I'm going to get rid of this. And that way I could see a little bit more clearly the part I care about. So basically anything up here is an answer. All of this is above both of the lines. Okay? So the first thing we want to do is you need to know how to shade it. So you have to be able to do two things. You have to know which line is which, and you have to know where to shade them. And then you look for where they're overlapping, okay? If you have an eraser, maybe start light and then erase the parts that don't overlap, right? Like I did. Makes it a little bit easier. You don't have to, though. But on your test and quiz, I'll only have the area that matters highlighted. Just all right, now let's see if these points work. 0, 3. It's right here. Is that a solution? Let's put a Y there. Yes, it's in the shaded area. How about 0, -1? No. 0, 1. I heard a no. I heard a yes. It's on the line. Now, the ones that are on the line, you got to think a little bit more about. It can be on the line if the line is solid. Is that a solid one? Yes, it is. So that's a yes. And if you didn't know that, then maybe put a little note here. Solid lines are okay. Right? Now, I got a 3, -1. So this is 3, -1. Right here, what do you guys think? Well, look at your paper. It's on a dotted line there, right? Mine looks solid because I colored it, but on your paper that's a dotted line, so we're going to say no because now it's on a dotted line. Now I should have done this, but I didn't. I don't know what the coordinates for that point are, but let's go ahead and add E there. I'm going to guess. I'm going to say that's negative 1.5 and negative 2.5. I'm just guessing. But I picked that point on purpose because that's where they're intersecting. Do you guys think that's a solution? Kind of tricky. Is it on a solid line? Yeah. Is it on a dotted line? So who wins? Right? We know if it's on a solid line, the answer is yes. We know if it's on a dotted line, the answer is no. But what if it's on both? Well, you have to think about what is a solution to a system of equation. It's an answer that works for both. Does it work for both? No. So the answer is no. It's still on a dotted line. Okay. Now, if the lines were both solid, then all of those would be yeses. But in this case, the dotted line can be carried. So if it's in the shaded region, it's a solution. If it's not a solution. If it's on a line, it's a solution so long as it's on a solid line only. If it's on a dotted line at all, then it's not a solution. All right, so I've got one for y'all here to do. First of all, you got to do your shading, and I would recommend that after you do your shading, I would check with a neighbor. Matter of fact, I'll probably pause in the middle and ask you guys what your shading looks like, and let's see. And then I'll give you a little bit more time to work on the A, B, C, D, E part. So I'm going to ask Lily really quick. I know you guys aren't done yet. It's okay. I just want to make sure we get the first step right. Lily, which one? Yeah, because that's the quadratic. That's the one with the square on it. So that's the U shape. Okay, which means that this guy is the other one. Now you got to do your shading. All right, so we have three possibilities. Is the overlapping area the gray, the purple, or the orange? I'm going to ask Crystal, what do you think? It is the purple. It is the purple. So let me explain why that is, and I'll have you guys kind of explain it to me as we go. So, first of all, for the straight line, Amaya, where am I shading for the straight line? We're shading above. Just pretend that parabola is not there for now. Color right over it, not a big deal. So we're shading above the green line. Now, Armani, where do I shade for the other one, the quadratic, above or below?
Below.
Right. Let me shade this one. I'm going to use blue this time.
Oh, it's below for the parabola?
For the parabola, it is below, yes. So it says y is less than. So that's, now, with parabolas, we're tempted to think inside and outside, but that's not that's going to be hard. But in this case, underneath of it would be down here. Don't you agree? So that's outside, if you want to think of it that way. But first of all, think of inside, or first of all, think of above or below. So think of above or below the vertex, and then from there, shade the rest. So you can see we're outside, so we're here. So we know that it can't be the orange area I had highlighted earlier, because that didn't get colored at all. We know it can't be this area inside the parabola because that part stayed blue. It's the yellow area where they're overlapping. So now that we've got that, I'm going to get rid of all this, and I'm just going to highlight the part that we care about. So it's a little bit more clear. And from there, I'm going to let you guys give you a little bit more time to talk about A through E. Okay, so there are our solutions. So now what we're going to do is we're going to, instead of me just giving you the graph and asking you to shade it, I'm going to have you actually create your own. But the only part that's new today is actually bold. We've already done all this stuff before, so just have to remember how to graph a little bit. So let's do that. All right, so example 2. Graph to indicate the solution to the system of inequalities. All right, so let's begin by drawing a graph. All right, for this I'm going to ask you a question. I'm going to ask Adriana, is this a quadratic or is that a linear function?
Quadratic.
That's a quadratic. So I'm going to follow the steps for graphing a quadratic, which is you start by looking for the vertex. So I'm going to ask, not David, but I shall ask Adrian, what's the vertex for this quadratic? Close. It's going to be positive 3, negative 3, because we want to remember to change the sign for that guy, right? So positive 3, negative 3 goes right here. Let me ask Edwin, happy face or sad face parabola? Happy, because the a value is 1, and when the a value is positive, we have a happy face parabola. If you had a negative in the front there, you'd have a sad face parabola. But before I draw my happy or sad face, Imaya, I'm going to ask you, should this be a solid or a dotted line? Notice that has no equal sign underneath. So do you think that's going to be a solid or a dotted line? Mm-hmm. So I'm going to draw a happy face, but it's going to be a dotted happy face with that vertex, just like that. Now we got to do some shading. So let's do our shading. Miles, where would I shade for this parabola? Above or below? Above, because once again, y is greater than, so I'm going to shade above. Now, as I've been noticing, you guys have had a little bit of trouble with shading the quadratics. I've sensed it today, so now let me see if I can help you a little bit. I said, think of the vertex. Where's above the vertex? Is it inside or outside?
Inside.
There you go. So if that's helpful to you, think of the vertex. Above the vertex is a good place to start. So now that that's inside, what we're doing is we're shading inside the parabola. All right, so there's that. Let's do the other one here. This one's missing some numbers. What is it? I'll use maybe I'll use a different color. All right, this one's missing some numbers. So I'm gonna. I guess I'll just ask and we'll see what happens. Shakir, what would you say is the vertex on this guy? You're close. You had the right numbers but wrong order. So this is the K, so it goes here, and the H is the one that's in parentheses. But since there's no parentheses, we could say that's a 0. So it's 0, 5, 0, 5, and that would be up here. So let's put a dot at 5 on the y-axis. All right, next question's going to Stephen. Stephen, happy face or sad face parabola? Sad face, because the A is a -1 here in the front, so that's a sad face parabola. Now we got to decide solid or dotted. So, Denise, do you think it's going to be a solid or dotted line?
Solid.
Okay. Let me.
Oh, dotted.
It's dotted because there's no equal sign.
Yeah.
So we're going to have a dotted sad face. So. All right, and let me ask Alondra, based on this, will we be shading above or below? Below. All right, so now once again, think of the vertex. Is below the vertex inside or outside the parabola? Is below inside or outside? It's inside again, but the reason why it's opposite this time is because it's upside down. But below the vertex is inside again. So now we can see the overlapping area there. So just for clarity's sake, I'm going to, if I can I erase this stuff? It's not erasing. Kind of is. Okay, that's terrible. Oh well. I'm going to stop erasing because I'm making it uglier. Alright. So what I'm going to do is I'm just going to shade in black this area here. That's where they're overlapping. So if I had a pencil and I could erase this, that's the area that I would leave shaded. Alright? And that's it. So now that's an example with two parabolas. Okay. Now we're going to look at two linear functions. So we get to review a little bit more here. So this is y equals mx plus b. We talked about graphing these yesterday, right? You start with your y-intercept and you move on into your slope. So let's do one of those. Let's draw a graph for number 2. Brittany, what's the y-intercept for this guy here? Good. So -3. So we're just going to put a dot right there at -3. 0, -3. Let me ask Brianna, what's the slope? 2/1. I like how you mentioned that as a fraction because that helps us know we have a rise and a run. I'm going to rise 2 and run 1. So up 2/1 puts me right about here. Armani, would I be shading, I'm sorry, solid line or dotted line?
It's a solid.
It is solid because there's a line underneath it this time. So that. And Lily, where would we shade for this one? Yeah. All right. Crystal, we're going to do the next line now. That one's done. Let's take a look at this one. Y is less than 2. What does that look like when there's just y and a number?
It's a horizontal line at 2.
It's a horizontal line at 2. So we're going to have a horizontal line at 2. So it's going to go straight across. But before I draw it, I am going to ask Amaya, solid or dotted? Okay. It's dotted because there's no line underneath, right? All right. And then I'm going to ask Cal, where do we shade for this one? Below? Yes. And so I can already see where we're going to end up shading here. I'm going to erase here on my highlighter. But I'm going to shade below the dotted line, and so that's going to be in this area down here. Okay, I'm not going to shade below over here just because I already see that's where the overlap's going to be. So this is where the answer is on this one. So just shade under the dotted and above the black, and that's right in there. Okay. Now I could, on this one I gave you, on number 1, 2 quadratics. On this one I gave you 2 linears. But you can mix and match them. You can have a quadratic with a linear. You just have to remember, okay, this one's a quadratic. This is the one where I got to look for the vertex and do the happy or sad face. Or, okay, this one's a linear, so this is the one where I start with the y-intercept and rise over run instead. So you have to know how to graph 2 types of functions here. So let me bring up your student practice here. I'm going to remind you. So as you're going through this, you want to ask yourself, is it quadratic or linear? Okay. Once you know that, you can graph it. After you graph it, you need to decide is it solid or dotted. After that, you're going to shade. And then you're going to repeat for the other one. So starting with this one, ask yourself quadratic or linear. Then graph it. Decide if it's a solid or dotted line, shading, and then repeat with the other line. Is it quadratic or linear? And so on. All right?
did a good job on graphing it, by the way. It is, let's see, with y is less than, which means below. So here's your vertex. Where's below the vertex? Right side. Cool, that one's good. So where's the other one? Oh, I didn't realize I left the recording on. Let's go through it real quick. Brianna, the first one here, is that a quadratic or a linear? It's quadratic. Right, and we know that because there's a square there, and that's the one, therefore, that has that U shape. So, Edwin, what's the vertex for this guy?
0.
Yeah, there's no H, so that's 0. The K is 5. So, let's go ahead and put a dot there. And then we shall ask Michelle, is this a solid or dotted line? Dotted, good. And then we'll ask Alondra, happy face or sad face parabola? So I'm going to have a sad dotted line here. Brittany, are we shading above or below the vertex here? Below. So below the vertex is there, so we're inside in this case. All right, next, Adriana, what kind of a function are we looking at here for the second one? That's a linear one. So that's the one where you start by looking for the y-intercept. So, David, what's the y-intercept on number 2? Dot there. Himaya, what's the slope on this one? The number in front of x. No, there's no number there. So what would that be? That's one of the options. What's the other option? In this case, it's 1. So we're going to go with 1. And as a slope, we want to think of it as a fraction, 1 over 1. All right. So I'm going to go up 1 over 1, rise 1, run 1, and that'll put me right there. All right, Miles, are we doing a dotted or solid line? And then, Aaliyah, where are we shading for this one? Above it. And in the green area, above it would be in here, so I like that in blue. But there's above the solid, or sorry, the dotted line, but also below the quadratic. So there's the solution of the system. So any point from this area would be a solution to these systems of equations. You could plug it in. It should work for both. And that's basically the gist of it. Okay? And that's it for today. So let me do one final spin around, check on notes, and then once I pass your desk, you're welcome to push